Alright, so with an incline problem like this, students probably struggle the most with finding the angle of their forces. Now, what's tricky about this type of problem is that we are used to living in a world where objects tend to move left, right, up, down. It's easier to work with problems that are on flat surfaces because we have these really nice vertical and horizontal axes, which we see in math class all the time. We see frequently. We're used to working with that, and you don't have to work with angles. What an incline problem does is it takes these axes and it rotates them to the same angle as the incline. So if I were to move this, you can see that this is approximately the same angle as the incline. So what helps is drawing your axes first of all on your picture. Then start drawing your forces. So I have a force of gravity that is acting on the box. The force of gravity is always going to point directly towards the earth. Or in other words, directly towards the ground, not towards the incline. My normal force is always going to be perpendicular to my surface. So my normal force should be pointing in the same direction as my vertical axis. Lastly is the force of friction. The force of friction is going to be opposing any desired motion of the object. I don't like how I drew that. So this box, if it were released and had no friction, would slide down the incline. So therefore, friction is going to point up the incline because friction is trying to oppose that motion. Now, what's difficult is figuring out, okay, what is the angle that my force of gravity is at? And you've got two options when you're trying to figure out your angle for your force of gravity. I'll do this in a different color. We can use either the angle with the horizontal axis, or we can use the angle with the vertical axis. I like to do the angle with the horizontal axis, personally. I'm a big geometry person, so I tend to see triangles everywhere I go. Now, I should have drawn this force of gravity a little bit more straight. I'll try and correct that right now. Your force of gravity should be vertical like this. And the reason I pay close attention to that is because if my force of gravity is directly vertical, it intersects with the base of this incline at a 90-degree angle. So what I'm looking at with this yellow triangle is a perfect right triangle. And my green double-lined angle in the corner is the complement of 25 degrees. What that means to be the complement of 25 degrees is the 25-degree angle and the double angle, my unknown angle, add up to be 90 degrees. I know this because all of the angles in my triangle add up to 180 degrees. So 25 plus 90 plus my unknown will give me 180. And I'm doing the math in my head because I know that when I subtract 90 from both sides, I get 25 degrees plus my unknown equals my leftover 90. So it's easier for me to jump to this step right here than adding up all of the angles to 100 to equal 180 when I know I'm going to subtract the 90 anyway and have to set it equal to 90. So I skip this step in the left corner altogether and I jump straight to the boxed assumption right here. So when I solve for that unknown angle, I end up getting 65 degrees. Now, I like that because I can see that in my head very quickly. I can do it relatively easily. The other way that you could do this problem, and I'm going to back up and undo this so I don't have to erase too much. Oh, niblets. Maybe I went too far. There we go. You could do this another way with a different triangle. There's your force of gravity. I've seen some people also look at the big triangle right here and they do a really good job at seeing that this is a 90-degree angle. So therefore, the angle in this bottom corner that I just marked with double green lines that you can't see all that well, this double green line angle is also the complement of 25 degrees. So what I mean by that is 90 is equal to 25 degrees plus this unknown. And we just solve for that unknown to be 65 degrees. Once you have this angle of 65 degrees, I'm going to erase the blue as best as I can.
Brianna, what are you doing?
As soon as I erase this triangle, I can mark another one right here, another 90-degree angle in the corner, the bottom left corner. I know this is 65 degrees, so therefore this upper angle is the same as the angle of my incline, 25 degrees. So either one that you choose to use, either method that you choose to use is totally up to you. Whatever makes more sense in your brain, I would suggest going with. But if you know your angle of your incline, you definitely know that the angle between your force of gravity and the vertical axis, the y-axis, will always be the same. And you know that the angle between your force of gravity and the horizontal axis, x, will always be the complement of the angle of your incline.